Okay, so let's begin today's session. Is my screen visible to everyone? Please react. Am I audible? Okay. So today's session is about inheritance and virtual functions. Now let's look at what inheritance is. Inheritance basically means borrowing properties of another class. It's like passing down properties from one class to another. These properties can be member functions or variables. So inheritance is basically used to get greater clarity and less code complexity. The main use of inheritance is that you don't have to write the same block of code again and again. It's used for reusing the code. So generally, protected and public members of a class are inherited and private members are not inherited. So in inheritance, we have two kinds of classes. One is the base class or the parent class. The other type is the derived class or the child class. So throughout the session, we'll be using the words base and derived. So derived class inherits the properties and members of the base class. Let's look at an example for inheritance. Here we have a class called faculty, which has some members. Then this is the syntax for defining for inheritance. So the keyword class followed by the name of the derived class, which is here we have a derived class called CS faculty. Then this symbol. Then here we have an access specifier word like public, private, or protected, which basically tells us that kind of inheritance. And then the name of the base class, the class from which we are inheriting the members. So this derived class CS faculty itself has some members. And then we have another derived class called EE faculty. It also has some members. So in this code on the right side, we have written the same thing without using inheritance. So these members, we have written it separately in the CS class and in the EE class as well. So this increases the complexity of the code. So when we have more than two derived classes or a high number, we can take out the common members of it and put it in a derived class, put it in a base class so that we don't have to write the same code again and again. So this simplifies, inheritance simplifies our job. So as we saw before, this word public. In public inheritance, all the public members of the base class are public members of derived class. Similarly, the protected members of base class are also protected members for derived class. So private members of here in all three cases, private members of base class are generally not accessible by the directly by the derived class. So in protected inheritance, both the public and protected members of base class are protected in derived class. And similarly, in private inheritance, the public and protected members of base class are private members of the derived class. Now here is a simple example to understand inheritance. So, so this is the code. You have to tell what the output of this code will be. What will happen when I hit run button? Please answer the poll on Slido. So this is the code. We have a class called base class. it has some members in it. Then for this base class, we have a derived class. It also has some members. And in main, we are creating an object ABC of the derived class. Then we are trying to access the print function of this object. So the print function over here prints the value of B. So this data member B is not there in derived class, but it's present in the base class. So will this code give an error or will it print the value of B as 9? Please answer this poll on Slido. All of you, please try to answer the poll. If you have any doubts, please put it on the chat, the Teams chat. I'll wait for another minute. So here the name of the object is ABC. So ABC is like one word. It's not A separate, B separate, C. Okay, so let's see what happens when you run this code. So it will print the value of B, which is 9. This is because when this print function is trying to access B. So here inheritance is private. So the protected and public, there's no public here. The protected member of the base class becomes a private member here in the derived class. So as we know, the member functions can access the private members of a class. So here B can be accessed and hence the value of 9 is printed. So coming to class pointers work like other pointers only, but they point to the address of an object of a class. So here we have a class named myClass with some members. Then here we are creating an object. We are creating a pointer called object pointer. So this pointer has a type of a class. So here we are defining this pointer as of the type my class. And this pointer is pointing to an object of my class which has been created using new. So new creates an object of my class on the heap memory and returns the address of it, and this pointer points to that address. So object pointer is of the type my class and points to an object of my class. To access the member variables and methods using this pointer, we use this arrow symbol. So now to access A, we see out object pointer arrow A. So it will print the value of 5. Then to access similarly to access the member functions also, we use the arrow. So here this is accessing the print function and it will print this. Base pointer to derived class. Over here, the type of the pointer, my class, is same as the object it's pointing to. That object it's pointing to is also of my class. But in this code, we have my class, which is basically a base class, and a derived class of this my class, which is called derived. So here we have created a pointer of the type my class, but it's pointing to an object of derived class. So see here, these two are different. So this is called base pointer pointing to a derived class. So let's see what this code will do. Ignore these commented out lines for now. The base class, which is my class, this is the derived class. Then in main, base pointer pointing to the derived class. Now we are trying to access the print function of this pointer, of the object to which this pointer is pointing to. Now here we see that this print function is there in this base class as well as the derived class. So which one will be executed? Let's run this code and see. So here the output is printing base. That means the print function in base class has been called. And this is because the function calls and all are executed here at compile time. So the compiler first sees the object type rather than the pointer type rather than the object type to which it's pointing to. So the type of the pointer here is my class. So in my class, it will search for this print function. And then it will execute this. So printing base will be the output. This is because the function call and all is executed at compile time. Now over here, in this derived class, we have another member, which is b, which is an integer. This is just unique to the derived class. This is not present in the base class anywhere. So using this kind of special pointer, let's try to access b. So this code has given a compilation error. Hence, we cannot access member variables and methods that are exclusive to the derived class. So here is another example. This is the code. I'll explain it in brief. Again, we have a class called my class. Over here, my class is the base class. And then we have a derived class of this called derived. In main, we have a class pointer of the type derived, which is pointing to an object of derived itself. Here both the types are derived, they are the same. And then we are trying to access print function of the pointer. So what will the output of this code be? Please answer it on Slido. If you have any doubts, put it on the chat. This is the code. I'll wait for another minute. Okay, so I'll run the code. The output here is base. Let's see why. First, this pointer tries to access print function of the object. In this derived class, there's no print function. But since it has inherited from the base class, my class, that too by public method of inheritance, this my class has print function, which is under public. So it will also be public in derived. So this function will be called. This in turn calls a function called answer. Now this answer function is present both in the base class as well as the derived class. It's the same function, just the definitions of the function are different, like what it's doing. So here, this has called the answer function in the base class and printed base due to the same reasons discussed earlier, and it has not printed this. Now let's look at another concept called virtual functions. Before that, in inheritance, multi-level inheritance can also take place. That is, there's a parent class, then inheriting from it, there's a child class, then there can be a grandchild class as well. So inheritance can take place on multiple steps or levels. Also, multiple inheritance can take place. That is, one class can inherit from more than one parent class or base class. By putting the word virtual before a function, it will turn into a virtual function. What it does is it shifts this decision making to runtime rather than compile time, as we saw earlier. So during runtime, the program checks for the most inherited version of the function and executes that. So over here, it printed base. If we write virtual before this and make this a virtual function. So now string is a virtual function. And then we run this. So it'll output derived. So now the decision of which function to call is being made at runtime instead of compile time. So the most inherited version of this function answer, so here there are only two classes, the base class and derived class, and the most derived or inherited version is here in the derived class. So this function gets called and derived is printed. So using the word virtual fixes the issue in the previous code. Now, as we saw earlier, the concept of base pointer to a derived class. Let's see that in the context of virtual functions. Here we have a base class, then a derived class of this base class. Then in main, we have a class pointer called ABC, which is of the type base class, but it points to an object of derived class. Now we are accessing the print function. So here this print function is present in base class and derived class. But the one of base class is accessed and base is printed. Since we have not used virtual functions over here, and the decision is made at compile time. So on this right side code, we have used virtual functions. So now here print is a virtual function. When we call this, the decision here is made at runtime. So this function of the most derived class, which is derived only over here. Or if it's confusing, the most inherited class, which is derived over here, is called, and the word derived is printed as the output. Now let us look at a special case where destructors are involved. This is the same code as written there, or the same code as previous ones. We have a base class, a derived class, we have just added a constructor to the base class, which prints base constructor called. And sorry, not constructor. This is a destructor to the class base, which prints base destructor called. And then we also have a destructor to this class derived, which prints derived destructor called. So in main, we have a base pointer ABC to a derived class. So now over here, since new is used to create and allocate memory by the rules of heap allocation, we have to use delete to delete this pointer ABC and call the destructors. So let's see what will happen when we run this code. So over here, the output is base destructor called. When we delete this pointer ABC, only the destructor of base class is called. But this is not efficient. We want to call the destructor of base class and the derived class as well to free the memory. So we put virtual before this destructor. So now when we run this code, derived destructor called, base destructor called, we get both these as the output. So over here, first the destructor of the derived class gets called and it prints this. Then the destructor of the base class is called and it prints this. If you have any doubts, please put it on the chat. Or on the Slido chat also. So that's all for the topic of today's session. If you have any doubts, please put it on the chat of Teams or Slido. I'll be here for 10-15 more minutes to clear the doubts. So over here, pointers an object of the class is created. The pointers are pointing to the address of those objects. So here, via these pointers, we are trying to access the members of the class. So that is a class pointer. I hope your doubt is clear. Any other doubts? So over here, we are creating the class pointer ABC of the type base and directly making it point to an object of the class derived by using new. So new allocates memory on heap for an object of the class derived and returns its address. And this pointer directly starts pointing to that address. So as we have used new over here to allocate this memory, we have to use delete to delete the memory once we are done using it. So if we don't write this delete over here, see here, nothing will happen mean, nothing is getting printed. So we have to use delete to free the memory, which is created using new. So new and delete are used for allocating memory on the heap. I hope it's clear. Okay, you wanted to see this program where the destructor is involved. So here, base class has a destructor, and this class derived also has a destructor over here. So by deleting this memory, these objects automatically go out of scope, its lifetime is over, and the destructors get called. So here, if we don't put virtual, only the base destructor will get called. But if we put virtual, both these destructors get called in the order, the derived one first, then the base. So the attendance link is over here. And please give feedback also for the session. Okay, so pointers in case of objects. So let's go back to the other code over here where we have used a pointer. So over here, ABC is a class pointer. It has the type derived. That is, class pointer should have the type of a class. Here derived is a class and it has the type derived. And new derived creates an object. We don't know the name of it, of the object created, but it just creates an object of this class derived on heap memory. And it returns its address of where the object was created on heap to this pointer ABC. So we don't know the object name here. We are directly accessing that object via this pointer ABC. So that's the use of pointers over here. See, if memory was allocated on stack, directly when it goes out of scope, destructor gets called as we saw in the previous sessions. But over here, when we use new, the destructor won't get called. We have to use delete also. So they are like a pair, new and delete. Okay, so you wanted an example of three classes case. So if answer was this answer string, the string answer, this function was present in all three classes, and it's a virtual function. So the one in the latest, in the most inherited class, that is, this is the base class. Then this is the derived class. Then again, we have another derived class of the derived class. So that will be the most inherited, and this answer function of that will be called. Attendance link is present over here in this poll. I'll just put it on the chats as well. Okay, 1 second. I'll clarify about the attendance link. And this attendance link was wrong. Just a minute, I'll send the correct link. I have sent the correct link on the chat. Everyone, please mark your attendance in that one. So over here, when you say two derived classes, do you mean like multiple inheritance or multi-level inheritance? I put the correct attendance link near the feedback form in Slido. Please check it out if you can't access Teams chat. So for this, we'll look at multiple and multi-level inheritance in future sessions in detail. I'm not very sure what the output will be, whether it will give the derived 1 class or derived 2 class, but you can easily code it up and see what the output will be. If you have any more doubts, please put it on the chat or Slido chat. Otherwise, you are free to leave the meet. Someone has raised their hand over here. If you have a doubt, please put it on Teams chat. And if you can't access that, on Slido chat. Oh, I was on mute while I was speaking, is it? So, what was the last thing you heard? I'm ending the meet.